Here's a little something maybe you didn't know about me, but I love music. I love writing music. I love playing music. I've been a musician for years, but probably most of all, I love listening to music. I listen to a wide variety of music, all different styles, all different genres, and I love the full spectrum of sound from the highest of highs to the lowest of lows. Probably the place that I listen to music the most is when I'm driving. I listen to it in the vehicle. But I got a problem in that vehicle. This is the subwoofer setup that I'm currently running, and it's bad. The box was originally made for a 10-inch speaker, and it's been replaced with a 12, so I know the airspace inside is not correct, and this speaker in general is just blown up. There's tears around the outside edge, it rattles and flops and just sounds terrible. So our goal for this project is to build a brand new, properly sized subwoofer enclosure that we can throw in the vehicle and hopefully get clearer low end. This is going to be a fun one. I'm Jeff and you're watching Homebuilt Workshop, so make sure you stick around. What's going on, everyone? Welcome to Homebuilt Workshop. I hope you're all doing great. I'm ready to get started on this project because it's been too long. I've been driving around with this blown up subwoofer. Sounds terrible. I'm tired of it. And today we're going to fix that problem. Before we start cutting some material, I want to preface this by saying I am not looking to break any sort of records. I'm not into competition. I'm not trying to be heard from blocks away. That's not my thing. But I do appreciate a good solid low end to whatever the music is that I'm listening to. So I'm not trying to build any competition system. I just need some more bass and need it to sound a little bit better. Before we can jump in and start cutting some material, there's a couple of things that we need to determine in order to make sure that we have this box sized correctly. It needs to have a certain amount of airspace according to whatever speaker you're going to use. So that's step one. You got to figure out what you're going to use. There's really only a couple of factors that I'm using to help me determine which speaker I'm going to use. The first is size. I already know that I want this box to be smaller than the box that I'm using currently, so that makes me choose a 10-inch subwoofer. It's going to be a lot smaller, requires less airspace, and save a little room in the back of the car. If you do a search for 10-inch subwoofers, there's still about a bazillion of them out there, different makes, models, different styles. How do you know which one? And that leads me to the second factor, which is amplifier size. The amp that I'm running, besides the fact that it's about 25 years old, but still works perfectly, we need to look at the power rating. The amp that I have is rated at 325 watts when it's bridged into 4 ohms. So I know that I need to have a speaker that can handle at least 325 watts. Remember, we're not doing competition here. I'm only going for sound. So it's got to be rated for 325 at a 4 ohm load. And that's pretty important because when you're looking at speakers, you're going to see them with ohm ratings and stuff like that. And without going into a whole lot of detail, just keep in mind that whatever the rating is on your amp, you've got to match that speaker to that ohm rating. So with those amplifier ratings in mind, here is the subwoofer we're going to be building this speaker box for. This little guy is made by Rockford Fosgate. This is a P3. This is a 10-inch subwoofer, dual voice coil at a 2 ohm rating. Now I know you're probably thinking, you just got through telling me it's important to match the ohm rating of your amp to your sub. You just bought a 2 ohm sub and you got a 4 ohm load on your amp. What's going on there? That'd be a valid question if you were thinking that. This is the only speaker I could find in the power rating I felt comfortable running on my amplifier. The other ones I was looking at had a lesser rating, which probably would have been okay, but I'd rather go a little bit over my rating and know I don't have to worry about toasting this speaker. But since this is a dual voice coil, which means we have 2 coils we're going to hook up. There's 2 sets of connectors on the back. We're going to wire them up and be able to double the ohm rating once we wire them up, and we're going to end up with a 4 ohm final load that the amplifier is going to see. So it's all going to work out. We'll cover that wiring just a little bit later. I think it's series, it might be parallel. We'll get to that later on. Probably the most important thing we're going to need before we get started is the owner's manual or the manufacturer's website. We're going to be able to look in here and find all the specs that we're going to need to build our box. Looking at the manual, it says our ideal box size for this speaker is 0.5 to 0.75 cubic feet for a sealed enclosure. So I'm gonna go with about that 0.75 cubic feet range. On the Rockford Fosgate website, they do have a really cool tool called the Box Wizard. And here you can enter in a bunch of dimensions and it'll calculate the airspace and kind of give you a roadmap for building your box. I took some measurements of my vehicle and played around with the dimensions here until I got to about that 0.8 cubic feet. Now I went just a little bit over than the recommended 0.75 because once we install the woofer, we're going to lose a little bit of airspace and I'm going to be just a little bit under that 0.75 cubic feet. It's going to be fine. With my dimensions from the box designer in hand, we're ready to grab some 3/4 inch MDF and start cutting. One challenge is my table saw does not work great for trying to work with sheet goods. So we're probably going to do the majority of the cuts here with a circular saw. That takes the challenge level up a notch, but I think it's going to work out fine. And from these two pieces, we should be able to get all of the remaining parts that we need to build this box. I'm going to try to do the remainder of these cuts using the circular saw as well. Now I do have a table saw, but trying to work with larger pieces really is not ideal. If you've got a larger table saw, more of a cabinet style saw, by all means, it's going to be much easier to be able to do that on a table saw. But like I said, these wider cuts, I really don't have a great way. My fence just doesn't work. So we're just going to do it the old school way. Can we call it that? We're just going to lay these out carefully, use a straight edge to keep the saw running nice and straight. See if we can do all this with a circular saw. I think we can. Did you guys just see me pull the trigger before I plugged in the saw? I bet you've never done that before. Now I'm just very carefully laying out the pieces that'll make the sides of this box. Originally I had these laid out to make these cuts separate, but I realized it was going to be a lot easier just to use this offcut, trace the dimension from the first piece. There's where I need to cut the second. That leaves me with a larger piece of scrap here that I might be able to use for something else. Now I'm getting ready to cut the piece that's going to make up the back. This is the last piece that has all 4 square corners. The rest of them are the smaller pieces that'll make up the front panels. Those are going to have angles cut on them. So far I have the back, the base, and the 2 sides cut out. I think I want to go ahead and get these glued together now. That way everything will be in place and we can get a little bit closer measurements as far as our angles and things for the other pieces that need to go on the front. All throughout this build, there's been one thing that I've kind of been thinking about, and that's the fact that there's about 1 million different ways that you could build a simple MDF box like this. Just because you see me building this box a certain way doesn't necessarily mean that you have to do it exactly like I do. We all have different goals in mind. If you do this sort of thing for a living, I'm pretty sure you're probably going to use a different set of techniques to build this exact same box. This is just the method that I chose to use because it works with what I have. We all have different shop spaces and different tools available to us, and I'm trying to keep this simple, yet still get the job done. Everything's looking good so far. All the joints seem to come together nice and square, which I'll take, considering the only tool we've used so far is a circular saw. We'll just let this dry for a little while, and we'll keep cutting the rest of the pieces. End scene. With the glue dry on the box, now I can cut the 3 final pieces that'll close this in completely. These are going to be a little bit tricky because we got to do some angled cuts, and I'm still trying to use just the circular saw. Now, in order to make sure that my process is good, I've already made the top piece as sort of my test cut. Voila! This piece fits right in here, if I put it the right way. I'm happy with the fit. I'm happy with the angle. Now I'm going to use that exact same process that I used for this to make the bottom panel. I'm going to use one of these digital angle finder protractor things. You don't have to use a digital one, but this is just what I have. We're going to measure this angle. I'm coming up with 141.6 degrees. If we do a little bit of quick math, I come up with 70.8 degrees. So now we'll set the protractor to 70.8 degrees, because the way I'm going to make these, I'm basically taking this angle, splitting it in half, and that's the bevel that I'm cutting on either end, so that when it comes together, it's going to be exactly this angle. At least that's the idea. Now I need to determine this distance right here. I'm going to carefully measure that as accurately as I can, and since I can't hook the edge of my tape measure on this, I'm going to start at the 1. And I come up with 14 and 1/8. So we take our 1 inch off, so I have 13 and 1/8. So I already have a bevel on the piece that I cut. The long edge of the bevel is the outside. So I'm going to flip this over, and from this edge I'm going to measure 13 and 1/8, and that's going to be where we need to put our bevel on the other side. Now I'll take my protractor that I've already locked down at half of that total angle, and I'm going to set the bevel on my circular saw to exactly that angle measurement. Lock it down. I think this is one of those applications where they say measure 800 million times, cut once. So the way this is going to work is once we flip this over and we make that same angle back together, that's going to be the angle of the side of our box. Now we just need to mark out where to cut this off right here at a 90-degree cut, and we'll have our third piece. And now a quick test fit of those pieces before gluing them in for good. Looks like maybe this one is just a little bit long. We could glue it together and probably sand it all smooth, but I want to see if I can correct that just a little. After thinking of several different ways to try to shorten this up just a little bit, not even the thickness of a saw blade, I thought maybe you could tilt the table on the bandsaw, or maybe try to do this again with a circular saw. I figured, well, for the little bit that we need to take off, we're just going to go old school and rasp it. Now this may not be perfect, but it doesn't really matter. As long as we get it pretty close, this is going to be glued together, and then we're going to screw it together once it's all glued up. So if it's off a teeny bit, I think it's going to be fine. Trying to maintain an exact angle with a rasp is definitely not ideal. I would much rather use a table saw at this stage, but again, the capacity of my particular table saw is so small, it makes working with wider pieces really tricky and sometimes even dangerous. If you have a table saw and can safely handle wider pieces of material, by all means, that is the way to go. It's so much easier and a lot more accurate, but this method does work if that's what you have to work with. You just have to be very careful not to change the angle as you work. After filing down the required amount of material, it's time to start gluing these pieces in place. I'm going to begin by gluing the 2 shorter end panels first. With those two pieces clamped in place, while I'm waiting for that glue to dry, I decided to cut the hole in the last piece for the speaker. I'm just using a protractor to mark out the circle. I'll drill a small pilot hole and cut out the rest with the jigsaw. Huh. Well, that's a drag when you look over after you just finished cutting out a recess for a speaker and you realize that the camera's not running. You didn't miss anything too exciting. I just used a jigsaw to cut a circle. Now before I glue this last panel in place, I want to take some caulk and just seal up all of these seams. I want to try to get this as airtight as possible, and by doing it now, while I can still get in there with full access, it's a little bit harder to try to reach through the hole. It's possible, I've done it before, but it's a lot easier if you get most of what you can now. Then we'll have to reach through and only have to seal up a couple areas. Finally, we're ready to add some glue and glue in the last piece. That was kind of satisfying to watch that squeeze out come out of there. While this piece fits in there pretty snug and would probably be okay to leave it as is, I'm going to use some clamps at a few different angles just to make sure everything's pulled in tight. This is definitely an awkward shape to clamp. Now just let this entire mess dry for a while, probably overnight. The next morning, I sanded everything nice and smooth using my random orbit sander. Then I rounded off all of the corners using a trim router with a 1/4 inch roundover bit. This will eliminate all the sharp corners. In order to reinforce these joints, I'm going to add some screws all around this box. Here I'm using a compass to mark out the thickness of the material that I'm going to be screwing into. This way I can drill right in the center. The last thing that I need to do is to drill a 3-inch diameter hole here to accept a little wire connector plate that'll be repurposed from the old box once we get to that step. To drill that hole, a hole saw would be the best choice, I think. However, I don't have a 3-inch diameter hole saw, but I do have a 3-inch diameter Forstner bit. This ought to be fun. At least it's wood. Hopefully it doesn't twist my arm off. That actually wasn't horrible, but you can see why I did this outside. And that brings us to the step of the project that I've been least looking forward to, and that's the finishing process. Now there's a lot of different ways you could finish a project like this, and a lot of that depends on your own personal preference and your end use goals for this particular item. Now I've seen people leave them just like this, bare wood. But I don't think that looks all that great, although it would be 100% functional. I've seen people just spray paint them a flat black or some sort of color, but just putting spray paint over MDF doesn't look all that great. Now, if you spend a lot of time filling holes and use primer and sand in between coats and all of that sort of thing, you can make it look awesome using paint. But what I've decided to do is to use some upholstery carpet, just like I used on the last box. This in particular is just some gray stuff that I picked up at my local auto parts store. It's actually really inexpensive. We're going to use some spray adhesive to attach this on here. Now I have built and carpeted several boxes over the last 25 years or so, but I'm not an expert in upholstery. We're just going to jump in and see if we can get this done. This should be plenty enough material to cover this and probably have a chunk left over for something later on. I'm going to turn this on its back because I want the seam to be on the bottom. I'm going to use some of this 3M high strength. This is the 90 spray adhesive. It's a contact adhesive. You could use the 77 as well. I've used that in the past, but recently I've been using this 90 for different applications, and it's a lot stronger bond. So if you really have something that you don't want to come apart, try out the 90. Not sponsored or anything, but this stuff does work really good. Shake well before using. Now here's something I haven't tried before. I've never tried using a J-roller to really press this stuff into the adhesive. But as I'm thinking about it, it might help promote a stronger bond. I'm going to cut this off. All right, so my seam is right here. And in the past, I've always tried to line up those seams, and that's probably the trickiest part, to try to get everything to come out lined up. I'm going to try something different. I'm going to use this straight edge. I'm going to go past the seam so that the straight edge is actually on both pieces of carpet, both layers. And I'm going to cut that straight across, basically cutting through both layers. My thought is that by cutting both at the same time, when I remove the pieces that I don't need, that they'll line up perfectly. I don't know if that's going to work. And that's not a bad seam. I'll take that. Now from here on out, to finish up this upholstery, I wish I could give you a whole bunch of tips and tricks as far as how to make nice, neat corners and seams and all that sort of stuff. But I don't have any tips and tricks because I don't really know any. Doing upholstery of really any kind has always been something that's been a challenge for me. So I guess this is the part of the video where I want to hear from you. If you have any tips, tricks, and suggestions for doing this kind of work on speaker boxes and cabinets and things, I would love to hear your suggestions. Go ahead and leave them down in the comments section so that I can learn from you. Well, it's not going to win any awards, but the box is covered in carpet. We're ready to start wiring this thing up. I've robbed the jack cup out of my old box, which already has wires soldered in place. Now we're at the part where we don't want to make any mistakes, because remember, this is a 2 ohm dual voice coil speaker and my amplifier has a 4 ohm load coming off of it, so we need to wire this up so that the amp sees that 4 ohm load. Since this has 2 voice coils, you can either wire it in series or in parallel. One of them is going to give you double the ohm rating of the speaker, so 4 ohms, and the other is going to give you a 1 ohm rating. It's going to cut the original rating in half. I don't think you're ever going to run these in a 2 ohm configuration with dual voice coils. I may be wrong on that, but I don't think there's a wiring configuration that's going to keep that 2 ohm load. So if you need a 2 ohm load, make sure you get the appropriate speaker. If I refer back to the owner's manual, it's got some wiring diagrams in here, as well as online. I just want to make sure that I'm wiring these correctly. Looking at the manual, it tells us exactly how we need to wire this speaker in order to have a 4 ohm load, which is what we need to work with our amplifier. There's also a ton of other options here depending on what you were doing, but for the single option that I'm running, this is how we're going to wire it right here. So the way this is going to work is we have a positive and negative coming in. Positive is going to go to positive on one side, negative is going to go to negative on the opposite side, and then we're going to connect the other two with a short jumper wire. And that's going to give us a 4 ohm load from this 2 ohm dual voice coil speaker. I know, it's kind of confusing. I'm a little confused by it myself, but that's how it works. These connectors are pretty cool because you just push them in, stick your wire in there, and let go. They're spring loaded. Kind of nice. Makes it easy to connect. and our positive there. And then I've got just this little short piece here we'll just use as a jumper. And just like that, our speaker is wired up correctly so that it has the proper ohm rating for my amplifier. Now we just got to zip in the speaker, add the trim ring, and we're done. This time around, I made sure to get the grill. That way it doesn't get all beat up. I really like how this looks. There's only one thing left to do. Well, I've got the box in the vehicle, everything's connected, it's working properly, and it sounds a million times better than the old one for a couple of reasons. One, because the speaker is not blown up, but I think more importantly is that the box has the right internal airspace for the speaker. It's a big key in making a speaker box sound good. Now I'd show you how this sounds, but, well, copyright kind of stuff, and we don't want to go there. So believe me, it sounds so much better, and I'm super happy to have this done. If you enjoyed this video, maybe you got some information out of it, go ahead and hit that like button. And if you like this channel and the wide variety of content we do here at Home Built Workshop, hit that subscribe, turn on notifications, all that good stuff so that you get notified when we release new episodes. Thanks a lot for watching. I'm gonna go crank up some tunes and drive around for a little while. We'll see you next time. I'm out of here.